Hi and welcome to this video on polygons, GCSE level, maths made easy. First of all, we're going to go over regular polygons. Now, a regular polygon can be inscribed within a circle, and the vertices or the corners of the polygon lie on the single circle, lie on that line that makes the circle. If it's got three vertices, 3 lengths equals size or equal length, then it's an equilateral triangle. 4 sides, equal length, 4 vertices, it's a square. 5 sides, 5 vertices, equal length of sides, pentagon. 6 vertices, lengths of sides equal, hexagon, heptagon, octagon, and so forth. So these names you've got to learn for the exam. Now, if we have a regular polygon, in the exam, most of the questions rely on us knowing a couple of facts. First one, that all the exterior angles in the polygon, if we add them together, they add up to 360 degrees. So if we have a regular polygon and we want to know the exterior angle, we get the number of sides, and then 360 divided by the number of sides gives us this exterior angle. If we have a look how we've drawn this exterior angle, so this would be 60 degrees for a hexagon. It's a straight line, and this is our exterior angle of 60 degrees. This is our interior angle, and the interior angle is the straight line 180 degrees minus the exterior angle, so this would be 120 degrees for a hexagon. If we draw a triangle from the 2 vertices of one of the sides to the center of the hexagon, or if it was inscribed within a circle, the center of the circle, we get an isosceles triangle, and this angle here of the triangle at the center is equal to the exterior angle. So for a hexagon it's 60 degrees. Here we're asked a question to calculate this angle here. So if we think about it in this form, where we've got the vertices, these are the 2 interior angles of the hexagon, and this is the angle we want to know. So the 2 interior angles are 120 degrees here and 120 degrees. So the angle to calculate this angle here is 360 degrees, which would be the total, minus 2 times 120, which is 240. Irregular polygons have lengths of sides which are different size, and these internal angles are different, and the exterior angles are different. However, the sum of the exterior angles, were to add them together, the sum of the exterior angles is 360 degrees. If we've got the same irregular polygon or any irregular polygon, we can draw triangles from one of the vertices to, when we join with a straight line to all the other vertices, this forms triangles. So the sum of the interior angles is 180 degrees, and in this particular polygon it will be multiplied by 1, 2, 3, 4, 5 times the number of angles we've got there, which is 180 degrees of each triangle. So a standard form is n minus 2, which is n means the number of sides, times 180 degrees. So that's the sum of the interior angles. And remember, as we said previously, the exterior angles add up to 360 degrees. Regular polygons, again we discussed this drawing a triangle from the center of the polygon, or the center of the circle that it can be inscribed in. We have an isosceles triangle when we join the center to the vertex of one of the sides, the 2 vertices or one of the sides. These 2 lengths are the same, and that's the radius of the circle. And then this is the same as the exterior angle, and this is the interior angle. The apothem, quite important when working out the areas of polygons. So the apothem is a line which joins the center of the polygon, or the center of the circle that it's inscribed in, to the middle of one of the sides of the regular polygon. So it divides the side exactly in half, 90 degrees, and it's to the center of the polygon. How do we calculate the length of the apothem? So the external angle is 360 degrees divided by 5, the number of sides for the pentagon, which is 72 degrees. The internal angle is 180 minus 72 degrees, which is 108 degrees. So when we draw this triangle from the center, we get a right angle triangle where this angle B is 108, which is the internal angle, which we calculated here, divided by 2. So this gives us this angle B as 54 degrees. We've got a right angle triangle, and we can use our trig rules to find the apothem, which is this line here of this right angle triangle. Remember, this is the radius of the circle, or the length of one of the sides, which in this case is 6 centimeters. This length here is half of 6 centimeters, which is 3 centimeters, and we can use one of the trig rules to find this length of the apothem. Here I'm using tan, so A equals tan of this 54 degrees multiplied by 3, which is 4.13 centimeters. Apothem comes in useful when we're working out the area of polygons. So we split the polygon into triangles. So triangle BCD has an area half of S, S being the length of one side. So area of a triangle, half the base times the height. So it's half S multiplied by H. And if we consider H as the apothem, the area of the pentagon is half S times H, which is now A, the apothem, multiplied by N, and N is the number of sides, or the number of triangles. We can split the polygon into number of isosceles triangles. This S and N we can multiply together, so we get half A S N in brackets, and the length of the side multiplied by the number of sides, that's the perimeter, so that would be this whole 5 sides, that's the perimeter. So we can write that as the area of a polygon is half A, the apothem, multiplied by the perimeter. Here we've got a little brain teaser, so stop the video here and try to do this. Giving you a hint here that this chord here, where it touches this tangent, and it's a circle, so look at circles, tangents and chords.